Hello. My name is Aurélien COLIN. I'm a PhD student working both at CLS and in the engineering school IMT Atlantique. I will explain to you some problematics of SAR imagery, especially on oceanography, and how we built a conditional version of a well-known GAN to help to tackle these problems. Currently, you can see an image of the South Shetland Islands. This is quite a complex image with a big atmospheric front, gravity waves, and a few wind streaks under them. We can also see some icebergs, or ships, but it is more probably icebergs. This scene is quite unique because it is rare to see such combination of phenomena. They do happen, of course, but are marginal compared to the vast quantities of ocean observations which we can access. The 10GOPS-RWV dataset contains nearly 40,000 of pictures of various meteoshean phenomena. Fronts, low wind area, icebergs, sea ice and so on. With this dataset, we are able to create a powerful categorizer, but with only the name of the phenomena, and image-level information, it is difficult to attack different problems such as segmentation or multi-label estimation. Annotating more examples would prove to be very costly as it would be time-consuming and require the skill of a SAR specialist. From this point, we consider the inverse problem. How can we generate SAR images with geophysical phenomena that we impose? Classical generation, meaning without labels, is something that has been done with success by the GAN name style GAN. It has also been shown that it was possible to edit the features of a picture, effectively turning it into a tool for data augmentation. From the second version of style GAN, released last December, we did some modifications to integrate the conditioning. The parts that need to change are the last layer of the generator and the first layer of either the generator or the mapper. The discriminator has to refuse an image not only if the result isn't similar to those of the dataset, but also if they are mislabeled, meaning that an atmospheric front was generated when we asked for a rain cell. For the other part, it depends on the assumption that we make on the topology of the latent space. If each class seems to have its own latent space, then the conditioning has to be put after the mapper. Then, each component of the latent vector will be interpreted differently by the generator, depending on the class. On the contrary, if we consider that SAR images live in a single latent space, then the conditioning has to be put at the entrance of the mapper. The latent vector W will integrate the conditioning in its elements. To measure the performance of this conditional GAN, we built a small website. On this page, the user is invited to select a name, and evaluate his own level in SAR imagery. After that, you will be presented SAR images and will be asked to guess if the image is real or not. This application uses the earliest version of the GAN, as we didn't have the possibility to redo an evaluation campaign. However, we can see that Level 1 users are easily fooled with a quarter of the fakes passing undetected. Level 5 are way better. Though they are also more defiant as some true images are categorized as fakes. Overall, these users were wrong 18% of the time. However, in this experiment, the data generation was done at resolution of 128 pixels. At higher resolutions, some high-frequency patterns appear on the real images that the GAN failed to imitate. At least, for now. To avoid this lack of high frequencies, we trained an independent GAN on lower resolutions, 64 pixels. The texture is then added after the generation of the low-frequency image. We have many ideas to increase the quality of the generation, for example using it to translate a picture from one label to another. That would help to get the high frequency as they would be translated from the input image. Ultimately, we hope that this architecture helps us to synthesize new pictures with specified features and be helpful for data augmentation, thus increasing the performance in categorization or segmentation. Thank you for listening.